Hello, ladies and gentlemen. Welcome to Math 31 Calculus, Chapter 3, Applications of Derivatives, Lesson 2, Acceleration, Part 1. Now, the acceleration is the rate of change of velocity with respect to time. Acceleration is the derivative of the velocity function. So, A of t equals v prime of t, or dv divided by dt. Acceleration is also the second derivative of the position function. A of t is v prime of t, which is the f double prime of t. Or acceleration is the derivative of velocity and the second derivative of the position. In Leibniz notation, acceleration is dv to dt, or d squared s divided by dt squared. Now particles speeding up when the velocity and acceleration are in the same... You fudge nugget! Stop that. Oh, you fudge nugget, you were out to get my last nerve. A particle is slowing down when the velocity and acceleration are in opposite directions. Now, let's see if I can do this without screwing up. Now, as a particle moves along the x-axis, its position at time t is given by x of t equals t divided by 1 plus t squared, where t is greater than or equal to 0, where t is measured in seconds and x in meters. So find the acceleration at time t. Okay. So right off the bat, x of t, our position, is t over 1 plus t squared. Now this is going to be f of x, or g of x, because I need the quotient rule, because velocity, which is the first displacement of the position, will be f prime of x minus f of x g prime of x over g of x squared. And yes, I'm still writing out the formula because I'm still making dumb mistakes here. So this is plus t squared is g of x times the derivative of f, which is 1 of t, minus f of xt times the derivative of g prime, which is 2t, over 1 plus t squared squared. So this is 1 plus t squared minus 2t squared over 1 plus t squared squared, 1 minus t squared over 1 plus t squared squared. Nothing cancels out. Well, I was kind of hoping something would. Occasionally you get lucky, and I'll show you. Now that's velocity. Now acceleration is the first derivative of velocity, which is the second derivative of the displacement. Now, if this is f of x, this is g of x. Notice I've already written the chain formula up here. I'm not going to write it down again because I'm lazy. This is going to be 1 minus t squared squared times the derivative of f of x, which would be minus 2t, minus f of x, 1, minus t squared, times the derivative of g of x, which would be 2 times 1 plus t squared, 1 times the derivative of what's inside the brackets, 2t. All of that gets divided by 1 plus t squared to the 4. And while you're all silently screaming a little bit on the inside, please note we can simplify. Please simplify as soon as you can, as often as you can. Notice 1 plus t squared is common to every term. 1 here, 1 here, and 1 here. Now, this becomes... Copy, new page, edit, paste. So let me see, multiplying this out, this becomes minus 2t plus 2t cubed minus 4t times 1 minus t squared. 1 plus t squared cubed minus t minus 2t. Let's see. Oh, that's 1 plus t squared, sorry. So that's minus 2t cubed, sorry. Too many, gotta double check your work counts. It's way too easy to make dumb mistakes here. Minus 2t minus 2t cubed minus 4t minus plus 4t cubed. 1 plus t squared cubed. Now, if you didn't cancel out the one plus t squared earlier, you would eventually. But so this is minus 6t. Let's see. Plus 2t cubed. Yeah. 1 plus t squared cubed. Now, traditionally, we would write this largest power first, so 2t cubed minus 6t over 1 plus t squared cubed. And yeah, you're really, if you're going to factor this out, sorry, if you're going to keep on going, you really should simplify it. 2t times t squared minus 3 over 1 plus t squared cubed. Now that's the acceleration. All right, that's a of t. Good? Now, I just want to point out, that's not the question. Find the acceleration at time t. Okay, I'm sorry, I misread the question. That's acceleration. Yuck. So the next question, when is it 0? When is the acceleration? Okay, so that is a of t. Just found it back here is 2t, t squared minus 3. 2t squared over 1 plus t squared cubed. When does that equal 0? 2t, t squared. I put the square in the wrong spot, sorry. Once again, double check your work. It's so easy to make dumb math boo-boo. Anyway, getting back to this, note, when does this equal 0? Well, you multiply both sides. If I taught you Math 30, then you know you multiply both sides by 1 plus t squared cubed. You get 2t times t squared minus 3 is 0. So either you're multiplying two terms, so either 2t is 0, or t is 0, or t squared minus 3 is 0, in which case t squared is 3, t is plus or minus the square root of 3. And careful, because we have a restriction back here, time is greater than or equal to 0. We don't care about negative time, so it's only plus root of 3. So when time is 0, right at the beginning, and time is square root of 3 seconds, is the acceleration equal to 0. Now, graph the position, velocity, and acceleration functions for t. Oh, great. So, grab your graphing calculator and graph these, because I am not doing this in my head. Life is way too short. All right. So, grab your graphing calculator. So, the first equation was, let's go back here. Of course, I put the calculator. Oh, here we go. Displacement is x divided by bracket 1 plus x squared, close bracket. Now, I'm going to make my window. I happen to cheat. Notice it's 0 to 4 seconds. Negative 2 to 2. I did this already. And I get a graph like that. Okay? So that is my displacement. So displacement will go this over. Oh, you poopy head! Stop that! People are watching. This is x of t. Now my displacement, sorry, my derivative velocity we found down here is covered by the graph calculator, of course. So y2 will be bracket 1 minus x squared, close bracket, divided by bracket 1 plus x squared, close bracket, enter. Oh, I'm going to make that thicker and graph it. And there we go. So that's what that one looks like. So that's my velocity. So velocity goes now. The third graph, my acceleration, is right here. Now graphing that's a pain in the bum, but we can do that. This is 2x bracket x squared minus 3 close bracket divided by bracket 1 plus x squared close bracket to the power of 3. And then graph that. And there we go. So that graph goes something like sharp. Something like that. All right. Well, can I make that? I don't believe I can do a third line with this, and I don't have the fancy color. No, I don't want it lesser than, I don't want greater than. I can do it this way. Hard to tell. Now, if you wanted distinct data points, of course, the nice thing about this is you do have a data table. So you can look at your displacement, velocity, and acceleration. And remember, I was talking about what is it, speeding up versus slowing down? Velocity and acceleration in the same direction? Anyway, that's enough of that question because we're running out of time. Actually, I'm going to pause it now because this is getting way too long. I'll finish the question in the next video. Any questions, shoot me an email.